Hello, my name is Merlin Christensen, and today we'll be talking about quadratic equations, what they are, where to find them, and how to solve them. A quadratic equation is an equation with y equals x squared term in it. At its most basic form, an example of a quadratic is y equals ax squared plus bx plus c, where a, b, and c are all constants. The rules of quadratics are pretty straightforward and simple when they're broken down. You can have a plus or minus sign in any of the spots, including negative or positive B and C. The biggest thing to keep in mind is that your constant A cannot be equal to 0. The other constants can be equal to 0 or any other real number. Now that we know the basic rules of quadratic equations, let's practice identifying what is and is not a quadratic. The term y equals x squared is technically a quadratic because there's an x squared term and you have the constant a equals 1. The other constants b and c would both equal 0, giving you just y equals x squared. The term y equals 4x is not a quadratic because there is no x squared term. A is equal to 0, while b is equal to 4, and c is also equal to 0. And this does not give you a quadratic. Now, when you graph quadratics, the same shape every time. The shape that is created is called a parabola. A parabola looks like this. A parabola can face either up or down depending on whether the quadratic is positive or negative. A parabola has many different parts that are very important to learn about. The most important thing to learn is of the axis of symmetry. That's what runs right through the middle of the parabola. The vertex is the low or high point on a parabola where it either starts to curve up or down, and it is also on the axis of symmetry. The majority of quadratics can be solved using the quadratic formula. The quadratic formula is x equals a negative b plus or minus the square root of b squared minus 4ac over 2a. What we want to do is solve for x in this scenario. Now, if we have the quadratic y equals 6x squared plus 11x minus 35, we can apply it to the formula and get x equals negative 11, which is that b term, negative b, plus or minus the square root of b squared, which is 11x, minus 4 times a 6, which is our a, times a negative 35, which is our c, over 2 times 6. Again, this is all just our a, b, and c constants applied to this. Now, when you solve the quadratics, you always get two answers. One for the negative b plus the square root term, and the negative b minus the square root term. You can get these answers by solving for x. In this example, the two answers are 3x minus 5 and 2x plus 7. We can find parabolas in many real-world applications all around us. One of the more common parabolas is the arch on an arch bridge, like you can see below. It takes the form of that almost U-shaped parabola. Another very common parabola people see is the arc of a rainbow. You can use quadratics in many engineering applications. The first thing I think of to use a quadratic is to visualize an arc in a construction project. But there are many, many more uses for parabolas and quadratics in real-world applications. Well, that's all I have for today. Thanks for listening to this. Remember, this is not a complete guide, only a supplement for proper coursework, and there's much more to learn about quadratics. So, thanks once again for coming. That's all I have. Bye. Hello, my name is Merlin Christensen, and today we will be talking about quadratic equations, what they are, where to find them, and how to solve them. A quadratic equation is an equation with a y equals x squared term in it. At its most basic form, a quadratic is equal to y equals ax squared plus bx plus c, where a, b, and c are all real number constants. The rules of quadratic equations are pretty straightforward and simple when they're broken down. You can have a positive or a negative sign behind any of your constants. The biggest rule is that the constant a cannot be equal to 0, because then you would not have an x squared term. Any of the other constants can be equal to any real number, including 0. Now that we know the basic rules of quadratic equations, let's practice identifying what is and is not a quadratic. The term y equals x squared is a quadratic because there's an x squared term and a would equal 1, while b would and c would equal 0. So you have all your constants, including an x squared term. The term y equals 4x is not a quadratic because there's no x squared term. This is because a equals 0, which is, again, our biggest rule we have to look out for. Quadratics also always form a shape which is called a parabola. When you graph a parabola, you always get a U kind of curve shape to it. But they don't always turn out as U's. Sometimes they turn up as upside down U's. So parabolas can face up or down depending on whether the x squared is positive or negative. A parabola has many different parts that are very important to learn. The most important thing is the axis of symmetry, which is the middle of a parabola. The vertex is the low or high point on a parabola, and it's where it starts to curve up or down. It is also along the axis of symmetry. The majority of quadratics can be solved using the quadratic formula. The quadratic formula is a fairly complex looking formula. It is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And what we want to do to solve is to solve for x. Now, if we have the quadratic y equals 6x squared and 11x minus 35, we can apply it to the formula. And we can remember 6 is our a constant, 11 is our b constant, and minus 35 is our c. So if we keep all of that in mind and apply it to the formula, we get x equals negative 11 plus or minus the square root 11 squared minus 4 times 6 times negative 35 over 2 times 6. Now that sounds very complex, but most of it can be broken down into much smaller and easier to solve parts. Now, when you're finished, you should have one answer for the positive and one answer for the negative. This is from your minus b plus your square root term and your minus b minus the square root term. And in this example, the two answers are 3x minus 5 and 2x plus 7. And now we can find parabolas in many real-world applications around us. One of the more common parabolas that you can see is the arch on an arch bridge. Another very common parabola is the arc of a rainbow, which you can see on a rainy day. Now, there are many more engineering applications that you can use quadratics on, but the first one that I think of is to visualize the arc on a construction project. But of course, there are many more parabolas and quadratics that are used in the real world. Well, that was all I have today. Thank you for coming, and remember, this is not a complete guide. There's still much more out there to learn about quadratics. Happy hunting!